Right, hello Year 10. So, last lesson we learnt about how we use radio waves, and moving up through the electromagnetic spectrum, we do need to understand what the uses of all electromagnetic waves are. So, a couple of things I'm just going to go through with you now. The first is the next type of waves after radio waves, which is microwaves. How do we use them? Well, we use microwaves for cooking, but how does it actually work? Okay, so in order to explain that, I'm just going to very quickly show you. Okay, now you're all very familiar with this molecule. Obviously, this is water. So the way that microwave ovens actually work is they or basically all the food that we pretty much eat has water contained within it. So what happens is when water molecules are exposed to microwaves, the water will absorb certain frequencies, basically microwave frequencies. So say, for example, something really high energy like a gamma ray. I literally cannot draw. Hold on a moment. Okay, sorry about that. So say, for example, you had high frequency waves like X-rays. Now what would happen is X-rays would pass straight through water molecules and nothing would happen. However, say, for example, you had waves with a longer wavelength. What happens is as this wave passes through the water molecule, what will happen is that energy is absorbed by the bonds in the water molecule. And as the energy gets absorbed, what happens is it starts to vibrate. Okay. And as it vibrates, we know when things move around more, they have more kinetic energy. So what do? They heat up. That is essentially how microwave ovens cook our food. So they absorb energy from the range of wavelengths that are microwaves, and the bonds between the molecules will vibrate, causing them to heat up. So what I'd like to do is pause the video and just quickly explain how microwaves allow our food to be cooked in a microwave oven. So let's just put the task in. Basically, how do microwaves cook food? Okay, essentially, water molecules will absorb the energy of particular frequencies, basically microwave frequencies. What that means is, once I've absorbed that energy, the bonds between the hydrogen and oxygen molecules in water start to vibrate. As they vibrate, they heat up, as things do. They've got more kinetic energy, and so therefore our food gets cooked. Okay, so pause the video and just do that now, please. Okay, so the other thing you will need is you'll need these two diagrams. I'm just going to explain to you what happens because sometimes electromagnetic radiation can interact with matter. Because remember what electromagnetic radiation is. It's basically energy being carried as a wave. So if an atom, a particle, absorbs energy, this is what happens. So here we've got an atom, could be anything, and here's our energy coming in of a particular wavelength. Again, I know it's badly drawn. What happens is when an atom absorbs some of that energy, the electrons will jump up to the next energy level. Okay, so basically this electron, it got some energy, it got excited, and it jumped up to the next energy level. That's what happens. So if I just put that down, an atom can absorb electromagnetic radiation. This causes the electron to jump up a level. Okay, so that's what happens when this energy interacts with stuff, with matter. Okay, so you'll need that in your book in a moment. But similarly, what will happen is a similar kind of atom, so same atom, they don't like being up here in this energy level. It's not their normal habitat. Everything likes to have the lowest energy state. So what will happen is it will drop back down. So the electron will drop back down to its original energy level. But of course, in doing so, it loses that energy. And that energy can be emitted as electromagnetic radiation. Now, what does this mean? Well, for example, if an atom absorbs, say, light, say a dark surface. Okay, so this was an atom of, say, some dark material, say black a carbon atom in a black t-shirt. Then what would happen is the energy would come in, the electron would get excited and jump up a level, so this is, say, visible light. But as soon as it's absorbed that, it drops back down. As it drops back down, it loses its energy, and so it gives that energy out as electromagnetic radiation. Maybe as a different kind, maybe as, say, infrared, so as heat. Okay, different frequency. But an atom can emit electromagnetic radiation when an electron loses energy. The electron falls down a level and the energy is lost or give out as electromagnetic radiation. Okay, so what I'd like you to do is I'd like to pause the video and like to copy these two diagrams into your book with an explanation of what's happening. So pause it now, copy these two, and I'll just move the screen down so you can copy the two explanations into your book. Okay, welcome back. So I'm just going to quickly move the screen down, just move it out of the way so you can copy that into your book. So there are the two explanations. And then also a little bit in green as well. So as the energy is absorbed, the electrons will jump up or fall back down and absorb or emit electromagnetic radiation. Okay, so the next part, wouldn't normally do, but what I'm going to ask you to do is use a video link in YouTube that I'm going to give you, and I would like you to make notes, particularly on the uses of the electromagnetic spectrum. So that's going up through radio waves, through to microwaves, infrared, visible light, X-rays, and then gamma rays. Okay, now the video is about 15 minutes long. So what I would then like you to do is use page 78, 79, and 80. That covers all the uses of the electromagnetic spectrum. I'd like to make a spider diagram based on the information from the video and your revision guide. Okay, so things today you should have. You should have an explanation of how microwaves cause water molecules to vibrate and heat up, and that's how microwaves cook food. You should have an explanation of how atoms absorb electromagnetic radiation, causing the electrons to jump up an energy level. That's how they absorb. And how matter, so atoms, stuff, can give out electromagnetic radiation, because what happens is the electrons fall down a level. So as they do, they give off energy. Incidentally, this is one of the ways we were able to get X-rays, because if you put energy into a material called tungsten, it gets energy and the electron jumps up, but then as it falls back down, it gives out X-rays, and that's how X-ray machine works. Anyway, little footnote for you. So you should have those two diagrams, and then I would expect a whole page in your book of a spider diagram linking the uses of all the key parts of the electromagnetic spectrum. So basically, radio waves, through microwaves, infrared, visible light, ultraviolet, X-rays, and gamma rays. So those are the types of electromagnetic waves. You need to make sure you get the order of them correct, and you also need to make sure you know how they are used. That is really, really important. So essentially a whole page spider diagram using notes from the video, which is going to be an assignment, and using page 78, 79, and 80 in your revision guide. If you don't have that, I will upload the diagram picture of that so you can have that for lesson 5. Okay, everyone, so good luck, and I'll be online if you need me.